Now quickly, we're going to move to homologous series and functional group. So we have homologous series. First, and then we'll talk about functional group. So what do you mean by homologous series here? Homologous series is simply a family of organic compounds uh, following a regular pattern, right? In which, following a regular pattern, which is systematically arranged. It is systematically arranged, and in which each successive member differ by CH2 or 14 grams. So what we mean by this is that organic compounds generally have a lot of families, and because they have a lot of families, because they are so numerous that they have been classified into their major families, and these families, they have something in common, and that which they have in common was following certain pattern, which we call a structural pattern, a regular structural pattern. So with that structural regular pattern, we have been able to classify each one of them under a family. So the system of arranging them with such pattern is what we call homologous series. So examples of compounds following this series, we have the alkane family. It's an example of a homologo. We have the alkene family. We have the alkyne family. So there are more than this, but we'll focus majorly on these three. So, and then tell us what is it that we need to understand about them. So the first one, the alkane family. So first, the alkane family, they have single bond all through. Right? Single bond. And the first member is a methyl. So we want to look at how they follow the pattern of a homologous series. If you look at the first one, with one carbon single bond, that's the methane. So that's called CH4, methane. The second member is going to be 1, 2, right? That's CH3, or we call it C2H6, that's ethane, right? The next member will be C23, right? Because of time, let me quickly put the C3H8, so that's a propane. So looking at each successive member, you come to realize that each successive member differ by CH2 or 14 grams. Let's see. And the way they are arranged, they are systematically arranged. They follow a regular pattern. Number 1, number 2, number 3. So the first and the second. Let's subtract the first from the second. So we are going to have this minus this. So it's going to be, let me take it here, C2H6 minus CH4. So what is going to be the difference? C1H2. So that means the difference between the two is what? CH2, which is CH2 or 14 grams. How do we link it to 14 grams? Because this is the atomic mass of this is 12, and the atomic mass of hydrogen here is 1 times 2, which is 2. 2 plus 12, that's 14. So that's why we have 14 grams here, or CH2. So you can do the same thing with this and this. So you have C3H8 minus C2H6 is also going to give you CH2 or 14 grams. So that's how alkane pattern follows. That's why the alkane family follows the homologous series. And generally they have a formula which is CnH2n plus 2. So this formula is a formula for any alkane group. And let's affirm the use of this formula here quickly. So for example, we can have, when n equals to 3, for example, So substitute value of 3 here, you are going to have C3H2 3 plus 2. So that will give you C3H8. So C3H8 stands for what? Propane. If you draw the structure, you get propane. 1, 2, 3. So that is, we use this formula to get the structure of any given alkane family when the number of carbon is known. Number 2, let's confirm how alkane family follows this pattern too. So for alkene family, you should not forget that alkenes used to have double bonds. So if I have an alkene family, double bond is very pertinent and important. So for example, the first member is going to be this. This is the first member of an alkene. So this is C2H4, right? So this is called ethene, right? The next member is this, right? So shouldn't forget that every member has 4 bonds. So every carbon atom has 4 bonds. So that's why we have this. So this is C3H6, right? So because we have this, and this. So if I want to take the next member, for example, I'll have this. Okay. So that will give me C4H8. So every member differ by CH2. This minus this. That was going to be C3 minus C2. That will give me C. 6 minus 4. That will give me 2. So that will CH2. Difference between this and this is also CH2. 4 minus 3, that's 1. 8 minus 6, that's also 2, CH2. So that's why this also follows that pattern. And the general formula here for alkene group is CnH2n. This stands for the general formula of any alkene group. So you can do that, for example, when you have n equals to 6. If I want to get the alkene, just substitute value of n into this. You get C6H2 6. So that will give you C6H12. So this stands for what? Hexene. So that is how we do this. And lastly, under this, we look at alkynes and how it follows the pattern. So, for example, triple bond for alkynes. We know triple bond for alkynes. So the first carbon bond is this. So this is the first family. Okay. So this is going to be called ethyne, and it is C2H2. So the next member is going to be this, right? So that's C3H4, right? The next, this is propyne. The next member will be 1, 2, 3, 4, right? So this is C4H6, right? So if we do, this is called butyne. So if you do the same thing with this, you get to realize that it's also giving us CH2. So difference between this and this, that's 3 minus 1, that's that's C, and 4 minus 2, that's CH, that's 2. So that will give us CH2. The same thing with this, CH2, and so on and so forth. So the general formula for this is this minus 2. So for example, if n equals to maybe 5, so I'm going to have C5H2 5 minus 2. So that will give me C5H8. C5H8. So this is called pentyne. So that's how to derive their structures. So quickly, let's look at what are their what we call their general properties. So the general properties for homologous series, or we call them features. Number 1, they have similar method of preparation. So the method used in preparing any alkane, maybe the method used in preparing alkanes is going to be the same as the method you use to prepare any member of the alkane. Methane, propane, butane, ethane, and so on and so forth. So the procedure used in preparing any of the members of alkane is similar. Number 2, they have same functional group. So the functional group are same. So the functional group of alkene, for example, is single bond, alkene is double bond, alkyne is triple bond. So the functional group is always same. Number 3, right? The successive member differ by CH2 or 14 grams. So every successive member differ by CH2 or 14 grams. So this is also very important here. And then, so also, when the number of carbon is increasing, the physical properties changes, right? Physical properties changes when number of carbon increases. For example, for alkenes, from number 1 to number 4, alkenes are gases, right? From number 5 to I think number 8 or 9 or thereabout is liquid, while the other fractions are solid. So as the number of carbon is increasing, the physical property is also what?